afternoon. Today we're going to solve this problem using Norton's theorem. Okay, so remember in Norton's theorem, we're going to short the load. Unlike Thevenin where we open it, here we're going to short it. And you can see over in the Norton's equivalent equation where I got I Norton in parallel with R Norton in parallel with my load. I've already put the load over there. One thing I like to do, and I'd like to have you guys do, so you don't get confused, I just take this out and put my short right in there. Because you don't want to add it in when you're doing your equations. So the easiest way to get my current A to B here is to do mesh analysis. So we got I3 over here, I2, I1, and then we can go write our equations. So the first one, everything touching I1, 1.5K I1, minus what's touching I1 and I2, 500 ohms I2, minus what's touching I1 and I3, which is 0, equals, I had a negative 50, take it to the other side, it becomes a positive 50. Then we do I2, everything touching I1 and I2, negative 500 I2, or I1, sorry. 1. Plus everything touching I2, which is 4.25 K I2, add these three together, minus what's touching I2 and I3, 750 I3, equals no voltage source, so equals 0. When we do I3, everything touching I1 and I3, 0 I1. Everything touching I1 and I2 minus 750 I2, plus everything touching I3, which would be these two, 5.75 K I3 equals, well, I hit the positive side first, take the other side, it's a negative 30 volts. Then I'm going to punch all these into my simultaneous equations. I'm going to get I1, I2, and I3. And I got I1, came out to 34.4 milliamps. I2, 3.2 milliamps. And I3 came out to a negative 4.8 milliamps. I don't really care that it came out negative because the only one I care about is I2 because that's the one going between A and B. So that is my I Norton. So I'm going to take and put that over here, 3.2 milliamps. And it is going A to B, so it's positive. So my arrow points up. Then we got to come back to our original circuit and we got to get R Norton, or our total in this circuit. So we have to take out our batteries and we short them. And then we go back to where our load was and we either put in our fake battery, or I like to put a little I. We look back from there and we're going to get our R total. I'm going to have my 1K in parallel with my 500 ohm. And on this side, I got 5K in parallel with 750. And if I do those calculations, this one comes out to 333.33. And this one comes out to 652.17. Well, that 333 is going to be here. The 652 is going to be here. Now these three are in series with each other. So I got 333.33 plus 3K plus the 652.17. So my R total is 3.99K. That's my R Norton. So I'm going to put 3.99K in here. So now I got my Norton equivalent circuit finished, but what I want is the voltage drop across the load. The easiest way I see to do this is I put my 3.99K in parallel with my 2.5K, and that gives me 1.54K, and I'm going to multiply that by my I Norton, so 1.54K times 3.2 milliamps, and that'll give me a voltage drop across my load of 4.92 volts. That's the ultimate goal, is to find that voltage drop across the load. Thank you and have a nice day.